1, 2, 3, 4, 5, 6, 7. Okay, I'm back. Okay, it may have not even showed up that I took a break there. Alright, but here we have, we were talking about the protein groups and the lipid groups. The steroids and fatty acid derivatives, okay, they're going to have a very, very distinct change in what's going on in the body as opposed to the protein group. Okay, control the secretion rate. Negative feedback mechanisms will play a major role in maintaining homeostasis, just like they always do. Okay, the control of the secretion of most hormones is done through negative feedback mechanisms, because positive feedback mechanisms, remember, if you get a little bit going on, it starts bumping up, higher and higher and higher, adding more and more secretion if it were a positive feedback loop. Remember, the negative feedback loops maintain homeostasis because it's just like your air conditioner. Okay, anytime it gets hot enough, the air conditioner kicks it back on and brings it back down to a normal level, so it stays within a normal range there. Okay, hormone secretion. Hormone secretion from an endocrine tissue is regulated by one or more of these three mechanisms. Either changes in the extracellular concentration of a non-hormone substance, or stimulation by the nervous system. Okay, if it's stimulated by hormone from another endocrine tissue, that's also another possibility. Okay, here we're going to try and see how this works if we play this through the video, but it may not work through the video mechanism which I'm using here. Okay, it did not. Okay, I apologize for that. Please watch that video in the lecture PowerPoint that you have. Okay, it should open fine. Okay, hormone transport and excretion. Okay, hormones are dissolved in plasma or they bind to plasma proteins. Okay, in that case, these hormones dissolved in plasma are water soluble. Okay, if they dissolve in plasma very well, they're water soluble hormones typically. Okay, these are proteins, epinephrines, norepinephrines. Okay, and they do not bind to plasma proteins or readily diffuse out of the blood. Okay, they do not bind to plasma proteins, nor do they readily diffuse out of the blood. They stay in the blood. They are quickly broken down by enzymes, or they're taken up by tissues. One or the other. Okay. Either taken up by tissues or broken down by enzymes. These hormones regulate activities that have a rapid onset and a very short duration. Okay, we're going to flip that now. Lipid-soluble hormones and thyroid hormones are on the opposite side of the spectrum. They're not quickly removed from the blood, okay, and they produce a prolonged effect. So if you were to list them in, how long they affected, you'd have your neurotransmitters, okay, in the nervous system. Then you'd have water-soluble hormones in the middle. They're kind of in between. And then you'd have the lipid-soluble hormones that will last a long time and they have a long-term effect. Okay, hormones that leave the blood to reach target tissues, okay, they leave the blood to reach target tissues, or they're excreted by the liver or the kidney. Okay. Receptors, target tissues. Okay. Target tissues have receptor molecules that are specific for a particular hormone. Okay. Only cells with a receptor for a hormone will respond to that hormone. Okay. Only cells with a receptor for that hormone will respond to that hormone. Okay. So here, notice that these guys right here are not going to fit into the receptor site. Okay, they don't match up. It's just like a puzzle. Okay, if the chemical structures do not match up, they will not fit together and form an active unit, a cohesive unit. Okay, so these guys, these hormones, they can move around until they find another cell that they can bind to. Okay, I'm going to go ahead and